Welcome back. We're ready to start the process of understanding how to figure out shapes of molecules. And the last thing I told you when we finished up Lewis dot structures is that Lewis dot structures are not equal to shape. So whenever I want you to think about shape, what I need you to think about are magnets. And you know that when you have a magnet, you've got north and south. You've got and come on, you remember this when you were a kid. You could play with magnets for an hour and a half, right? If you had the magnets that looked like this or looked like this, let's look at this one first. Do you remember playing this game? I remember playing this game. You'd move the magnets closer and closer and closer. And maybe you'd move it close where it moved a little bit on its own, which is exciting. And then you'd move it just close enough and then go, shoo. And you're right, there's nothing better than giving yourself that scare, that jump scare, right? That's what happens when the north and the south are involved. The opposites attract. But whenever you have north with north and south with south, what would happen? You'd shove them together and they would fly apart because there was a repulsion between the same charge on the magnet, so to speak, right? There's an attraction here, but there's a repulsion there. Well, electron pairs repulse each other. Electrons are minuses, and electron pairs stay together when they have to, but electron pairs repulse other electron pairs. That's the key to everything. When we deal with shapes of molecules, what we do is we look at electron pair or electron environment around the center atom. Now, why do we deal with shape having to do only with the center atom? Well, you know, if you took pictures of 10 different people and all you showed was the picture of their pinkies, do you think you'd be able to predict their body shape, like how much they weigh based on just pictures of pinkies? I'm pretty sure that you wouldn't be perfect about it, like unless somebody had just one seriously huge pinky or incredibly anorexic pinky, right? Most pinkies look about the same, but when you talk about somebody's shape, you know, you look at the middle of their body, their torso. And it's the same thing with molecules. The shape of a molecule is about its center atom. Okay? And so what we want to do is we want to look at the electron environment around the center atom. Now, one of the things that Lewis dot structures allow you to do is determine what the electron environment around the center atom is. Okay? But then you have to be able to interpret it. You have to look at the electron environment and say, what does that look like? What is that? Now, anybody who's been involved with this before, and many of you do see this in high school before you get to this class, you might have heard about electron clouds. I had a professor who called it electron moieties, which of course, he immediately lost everybody in the class because who the heck knows the word moieties? It's insane, right? So I call them just electron places. Okay, I even sometimes call them things, okay? But the idea here is what we're talking about is counting the number of places around a center atom where electrons are found. Regions of electron density, electron clouds, electron moieties. I'm just saying places where there's electrons, okay? Because one single bond is equal to one place. Is that fair? If we looked at a atom and we saw one single bond, that's one place where electrons are found. Would you agree with me that a double bond attached to an atom is also one place where electrons are found? If you think about electrons being like a magnet, this is just a stronger magnet, but it's still just one magnet, right? And a triple bond is still one place, but it's just an extra strong magnet. And here's the thing that you have to understand about shapes of molecules, that if you get this, it's going to help you along. And by the way, if you can sort of three-dimensionally envision what's going on, this is a big help whenever you get to organic chemistry. It's down the road. You got to get through freshman chemistry first. But if this is something where you can envision it in your eyes, in your mind's eye, that's going to be very helpful as you go. And this is maybe the most tricky part to this whole process. It's not tricky, you just have to get the idea. One lone pair. All of this on the center atom is still only one place. It's still one place where you can find electrons, okay? Weak magnet, weakest magnet, strongest magnet. So if you have a lone pair around a center atom or on a center atom, that thing is the most repulsive of any of it. And a single bond is the least repulsive of any of it, okay? So if you can keep this in mind and recognize that we're dealing just with the center atom, that's a big start in understanding shapes of molecules. There are lots of different shapes that you deal with. The ones that are dealt with in freshman chemistry the most are when you have 2 places, 3 places, 4 places, 5 places, and 6 places around a center atom where you can find electrons. In this class, we're only going to deal with 2, 3, and 4. And the next thing to think about is the idea of what is the way to minimize repulsion the easiest with 2 places, 3 places, and 4 places. That's next.